Hi everyone, and this is Science with Margarita. Let me introduce Margarita. Hi Margarita. She has her little coat off tonight, so here she is. She's kind of cold. And tonight we're going to be talking about centripetal force, which is kind of a weird thing, not what you think it would be. Basically, centripetal force is any force that can cause circular motion, and it's always perpendicular to the object's motion, which is kind of a really important thing. Let me zoom in on a little diagram that I made here, because you can't see it from here. Let's see. It's sort of tough to see, isn't it? Anyway, this diagram shows basically, say for instance, a ball is being swung around your head on a string, and if you look closely, the arrows point from the center of motion, your hands, which is the little mid dot there. The ball, hypothetically, if you were to release it, would go in the exact straight line of motion that it was released at. So the motion isn't really circular. The ball is basically going infinitely in small amounts in a straight direction. So instead of, the common misconception is that it just travels circularly, but if I was to release a ball over my head, it would fly in a straight direction, not go circularly. One sec here. Let's see, what else do we have here? So it's all perpendicular. And the motion itself is actually towards the center of the object. You think you're on one of those crazy carnival rides where you're being pushed against the side of the ride as it spins around and it feels like you're being pulled outwards. Well, really the force is actually inwards. It's the wall of the ride that's pushing you back, and that's what's making you feel like you're being pulled back. That was kind of hard for me to grasp, I'm not quite sure. Centripetal acceleration is kind of a very important thing too. In this centripetal scenario, an object can maintain a constant speed, but would always have a constant acceleration, which is kind of strange to think about. But then we have to remember that velocity is two things: it's magnitude and direction. So in a circular scenario, the object is constantly changing motion, which means that in result, acceleration by definition is a change in velocity's direction. So an object is changing acceleration constantly. And let's see what else. There's an equation here. I'm not going to interrupt and go and zoom in again, but it's force equals mass times the v right here. Let me find, v squared over radius, and that is the equation that you can sort of basically it cancels out to become meters per second squared, and that's very important to acceleration. Let's see. That's about it for centripetal force. Margarita had something to say. Come here, Margarita. You got something to say? No, I guess not. I guess maybe later. Alright. Thanks and good night.